Okay. Hopefully this works. But anyways, welcome guys. This is the first lecture video for adding and subtracting polynomials. We'll go through all of them. This is adding and subtracting polynomials. We'll then do multiplying polynomials. Yes, multiplying polynomials and then special products of polynomials as well. So when we get to adding and subtracting polynomials, in general, an expression which is the sum of the terms of the form ax to the k power, where k is a non-negative integer, is something we call a polynomial. There are other types of polynomials out there. This is a monomial, like a single one, but there are also ones that have, for example, like ax to the k power plus by to the m power plus c. This is like a trinomial. Then there's also something called a binomial. Every time we are writing a polynomial, they're usually written as, or rather written in standard form, which means that the terms are placed in descending order from largest degree to smallest degree. So for example, if we were to have something like x squared plus 2x plus 2, this is something, a polynomial rather, that's written in standard form. But if we have the same one, but we, kind of rearrange this, we may have something like this, 2x plus 2 plus x squared. This example here is not in standard form. A breakdown of a polynomial in standard form is we have something like this, where the first term in this polynomial will always have the highest degree. As you can see here, this has 3, while this has 2. This technically has a 1, and there's no degree here for this last term. Whenever we have a term that's in the very front of a polynomial written in standard form, the coefficient or the number that's next to our variable term is something we also call the leading coefficient, right? Something that is always going to be in the front. It's like leading the polynomial, while we have another coefficient like 5 or 4 that aren't leading coefficients because they are not in the front when a polynomial is written in standard form. Just more definitions, but the degree of each term of a polynomial is the exponent of the variable, while the degree of a polynomial is the largest degree of its terms. For example, we can say that this polynomial 3x squared plus x plus 2, the degree of this polynomial is going to be 2, while we can also say that the degree of this term, right, the degree of this term is going to be 1. That's probably it. Some nice examples here is that we can say that same thing, the degree of this leading term, this whole polynomial, the degree of it is going to be 2, while the degree of the singular term here is going to be 1. And same thing here, this 4. In actuality, it does have a degree of 0. Whenever we raise anything to the 0 power, it's just going to be 1, right? And we know that 4 times 1 is going to be 4, right? So that's some other things. I think we have another example here, wherein that we're just identifying polynomial coefficients. So in this case, we want to go ahead and identify the coefficients of negative 4x to the second power plus x to the third power plus 3. The coefficients here are just the terms in front of the variable terms, right? So for example, we have a negative 4 here. We also have a invisible 1 here in front of this 3. So we can say that the coefficients of this polynomial is just going to be negative 4 and 1. If the question were to ask you what's the leading coefficients, or leading, let me erase this real quick, coefficient. If we want to figure out what the leading coefficient is for this polynomial here, we have to rewrite this in standard form. So rewriting this in standard form, we're just going to go ahead and pick the first variable term that has the highest degree. In this case, it would be this x to the third power. So we can rewrite it as x to the third power minus 4x squared plus 3. Then we can, definitely identify what the leading coefficient is for this newly written polynomial in standard form, which should just be 1 in this case. And after this, we do have some more terms regarding what kind of polynomials you may encounter. A polynomial with one term is called a monomial, right? Mono meaning one. A polynomial with two terms is called a binomial, bi meaning two, so two nomials, so two terms. And finally, anything, rather a polynomial with three terms is something we call a trinomial. If you encounter a polynomial with more than three terms, we'd simply call them, let's just say 4 plus. It's going to be called a polynomial simply. Polynomial. In this case, this example here, x squared plus 4x plus 4, we'd call this a trinomial, right? It has three terms. We also, I think there's more examples after this. A term like this, 4 or more, right? In this case, it's going to be 4. We just call this a polynomial. Okay, now for the unfortunately fun part. We have to now find the sum of these types of problems where we have this polynomial plus this polynomial plus this polynomial, and in B, just two polynomials being added together. In these examples, we have two different ways to solve them. For letter A, I will do both examples, and then for letter B, I'll probably just choose one of the example. The first example that we'll go ahead and talk about with letter A is how can we solve this horizontally, right? So two different methods. The horizontal method is us just trying to group up similar terms together and then adding them, right? So for example, if we are just simply adding all of these terms together, let's just look within the polynomials and figure out what are the terms with the higher degrees, right? And we'll go in descending order. For example, if we're looking at this first polynomial, we notice that out of all four of these terms, 5x to the third power is going to be our bigger term, or the term that has the bigger degree. So we can go ahead and write in here our first parentheses here, 5x to the third power. From there, we'll look around and see if there's any other terms that have that same degree of third power. Our second polynomial here does not have anything to the third power, but we notice that in our last polynomial, we do have something with the third power, which in this case is x to the third power. In this case specifically, it does have a subtraction sign in front of this x to the third power. So what we'll go ahead and do is add a negative x to the third power instead. From there, we'll just go in descending order. We'll start from the far left and then look throughout all of the polynomials. In this case, in our far left one, we do have 2x to the second power here. We'll go ahead and write that in our next group. We also have a 3x to the second power. And last but not least, we do have a 4x to the second power here as well. From there, we can keep going down. We have a negative x here, so we'll write out negative x in our first polynomial. Our second polynomial, we do have a negative 4x, so we'll go ahead and write that in as well. And then in our last term, we don't have anything, so we'll just close off our second to last group. And last but not least, we have anything that has a constant. A constant is just any kind of term that does not have a variable attached to them. So in this case, our first polynomial, we have 7, so we'll go ahead and write that in, 7. We'll add another 7 to that. And finally, we'll then subtract 8 here. And all we have to do is just add all of the terms together in each of the groups. So our first group here, we have 5x to the third power plus negative x to the third power. In this case, we're just combining the coefficients. So 5 minus 1 would give us something like, let me just change my color here, 4x to the third power. So we can go ahead and also cross this out just to make sure that you know that we're done with this section. Our next group, we have 2x squared plus 3x squared plus 4x squared. Same thing as what we did earlier. We're just adding our coefficients together, 2 plus 3 plus 4. 2 plus 3 gives you 5, 5 plus 4 gives you 9, so we have a positive 9x to the second power. And likewise here, in our next groups, we're doing the same thing. Adding the coefficients together, we have a negative 1 plus negative 4. That gives us something like negative 5x. We could have also written it as plus negative 5x, but just to keep things a little bit simpler, we'll make sure that we include, I'm going to rewrite it, and I guess you can say simplify this already, just to avoid the headache. Last but not least, we have our constant. 7 plus 7 gives you 14. 14 minus 8 gives you something like 6. So this is us finding the sum of all three of these polynomials being added together. 4x to the third power plus 9x squared minus 5x plus 6 is our answer. Okay, I'm worried that my mic is not working, but we'll just keep going. Find out after I'm done recording if it worked or not, and have to record all this stuff. Anyways, that's us solving this horizontally, but we can also solve this vertically. It doesn't really matter how you solve it, in my opinion, but if your future teacher does ask you to solve it in a different way, then at least you know both the ways, right? So our next way that we can solve the same problem is the vertical method. The vertical method is just us making sure that all of these terms are written in standard form first when we write them out. So it's almost like we're solving something vertically, like for example, 651 plus 701, and we just add them straight down. 1 plus 1 gives you 2, 5 plus 0 gives you 5, and 6 plus 7 gives you 13, right? That's your answer. So same way, but we'll be using our polynomials to fill in those spaces. For example, if I want to write out my first term here, I'll go ahead and write it out as 5x to the third power plus 2x squared minus x plus 7. Then what I'll do for the next following polynomials is fill them in the same spots where they share similar degrees. For example, in our second polynomial, 3x squared plus 7 minus 4x, we don't have a term that has a third power, so in place of this, we'll go ahead and just write 0 here, right below our 5x to the third power. From there, we can start filling in the rest of the spaces. We have our plus 3x squared here, our minus 4x here, and last but not least, our plus 7 here. And for our last polynomial, we have same thing, no term with a third power, so we write 0 in place of it. We can say 4x squared here, right below this. We can then, whoops, sorry about that, my mistake. There should have actually been, yes, a negative x to the third power there. There's no x to the first power, so we can go ahead and just write a plus 0 in place of it. And last but not least, we have a minus 8 here. Now all it's left to do is just add all of these together. 5x to the third power minus 1. This gives you a 4x to the third power. 2 plus 3 plus 4 gives you, we said earlier, was 9. X to the second power. Adding negative 1 plus negative 4, we get negative 5x. And 7 plus 7 gives you 14, minus 8 gives you 6. So, same answer as we got previously, but just solved differently. Depending on which way you prefer more, you can choose how you want to solve these problems vertically or horizontally, whichever one you're more comfortable with. For our next problem though, letter B, I'll go ahead and add them vertically because, I don't know, I think it might just be a little bit faster since only 2 polynomials. So how do we solve this? Same thing, let's just line up all these terms all in standard form. So we have 2x squared plus x minus 5. We then have our second term, right? We have to make sure that this is going to be rewritten in standard form. So from biggest degree to smaller degree. So let's start off with this x squared first, then the x, and then the 6. Adding them together, 2x squared plus x, right? Invisible 1 in front of the x squared, so we get 3x squared. X plus x, invisible 1's in front of them, so we get 1 plus 1 gives you 2x. And negative 5 plus 6 gives you something like positive 1 as your answer, 3, 2, 1. So these same methods that we covered, both horizontal and vertical, we can also apply them when we subtract polynomials as well. We'll showcase some examples. I think we have some here. Yeah, we have some examples here. We'll go ahead and showcase how we can still use those same methods to solve problems like them, or like this. So when we have, let's say, a horizontal way to solve these problems, the main difference here is that inside the groupings, we have to make sure that we're subtracting them, right? Because we're subtracting polynomials. So in letter A, let's just try to solve this using that horizontal method. So we'll first group anything that has a third power together, but I'll go ahead and showcase to you how we'll go about doing this. So if we have, let's say, for example, negative 2x to the third power here, we'll write that out in our group, but we'll also make sure that we're subtracting negative 2x to the third power inside this group as well. Same thing, when we move on to our next group, what we'll do special is we'll go ahead and actually just write a plus, just to make sure that we're combining all the polynomial terms together at the very end. But remember, inside the grouping, we are subtracting them. So in this case, there's only one term that has a second power, which in this case should be 5x squared. So we can just write that alone by itself. We'll write our next term that we have, which in this case is x to the first power. So we have a negative x to the first power here. We'll go ahead and subtract it with this 3x. And last but not least, we have our last grouping, which should just be 8 minus negative 4. Then we'll solve. Negative 2x to the third power minus 2x to the third power, this actually becomes a plus. And we know that negative 2 plus 2 just gives us 0. From here, our next group, 5x squared remains. Here on our next group, at negative x minus 3x, same sign, so we add them, right? Negative 1 plus negative 3, this gives us negative 4x. And here, 8 minus negative 4, this becomes a plus, so 8 plus 4 gives us 12. In this case, we have this 0 here. We don't have to write that in, but we can rewrite it, so it looks like 5x squared minus 4x plus 12 as our answer for letter A. These next couple ones, we'll probably just do them vertically, I guess. That might be better. But horizontal, a little bit easier. In my opinion, I like the grouping, but the subtracting inside the groupings may throw some people off. Anyways, let's try out B. Yeah, there's no other easy way to erase any of this stuff, unfortunately. So it might take a little bit of time. So this question B, same way as what we did when we added the polynomials, but this time around it's going to be a little bit different. And we'll go ahead and showcase that. So we have our first group, in this case going to be this first term, whatever it is, x squared. If we're looking at both of the polynomials, we notice that in our second polynomial, we have something that has x to the x to the first power. So in this case, we want to fill in that spot when we first write out whatever polynomial we have first. And in this case, since our first term doesn't have it, we have to also include a 0 just to make sure that we... So we're done with polynomial here. We'll go ahead and also write out the second polynomial. In this case, it's just going to be 7x plus 4x squared. We'll write the 4x squared first, and then we'll also write out the 7x and add a 0 at the very end since this polynomial does not have a constant. From there, we'll go ahead and subtract them, right? we'll do, let's say, for example, x squared minus 4x. That's like saying 1 minus 4, which gives you negative 3x squared. Here as well, 0 minus 7x, this gives you a negative 7x. And negative 8 minus 0 should just give you negative 8 as your answer. So a little bit easier, I think. But the problem with this is that I think some of us might be a little bit confused when we have something like negative or 1 minus 4. That should always give you negative 3, right? Because we're subtracting them but keeping the sign of the bigger number, right? So if we're adding, let's say for example, 1 plus negative 4, negative 4 is a bigger term, and then so we subtract them, right? Different signs we subtract, so we get negative 3. Same thing as if we were to say negative 5 plus 2, right? We're still combining them, but because they have the different signs, we subtract them, but we keep the sign of the bigger term, right? Term that has the absolute value. So negative 5 is going to be negative 5 minus 2, so it gives you negative 3. From here, let's just do C vertically as well one more time. And then I guess at this point, if you want to try the reverse method, horizontal, you can do that on your own time, but I'm trying to make this video as short as possible, which is not going well. Anyways, letter C, we have 3x squared minus 5x plus 3. This is written in standard form, which is great for us. So we also have to just write our next polynomial, and thankfully enough, it is still written in standard form. So 3x squared minus 5x plus 3 minus 2x squared minus x minus 4. And we'll go ahead and solve this. 3x squared minus 2x gives you x squared. Negative 5 minus negative x. This becomes negative 5x plus x. So different signs we subtract, but we keep the sign of the bigger absolute value. Negative 5 plus 1. This gives you negative 4. So we can rewrite this as negative 4x. And same thing here, 3 minus negative 4. Double negative gives you a positive, so 3 plus 4 gives you 7 as your answer here for letter C. And I think that's it. Yeah, that's it for adding and subtracting polynomials. I'll stop the video here, but I'll see you in the next recording because I need to check if my mic was working.